So I think, Dr. Leo, we can start, but first I want to welcome everybody who has joined the discussion today. It's the African Tea Time, and our presenter today is Dr. Leo Zulu. And Dr. Zulu is a professor in the Department of Geography and also the interim director of the African Studies Center, Michigan State University. I will go ahead and just welcome him. Dr. Zulu, you can tell us more. At tea time, we give the speakers time to even tell us more about themselves before they begin, so we can warm up and get to know one another better. And I'm inviting everybody to, Dr. Zulu will give the presentation, and then at the end, we're going to have a discussion. And what I encourage you to do, please feel free to type your question on the chat or comment. And later on, we are going to give you time to raise your hand and verbally communicate or just engage the speaker and other members of the audience. So it's going to be a discussion, and you want to make it lively, please feel free to, type your questions or write them somewhere, and then be ready to ask them at the end. So Dr. Zulu, thank you so much for accepting to be here to lead us in this discussion on climate change, adaptation, and challenge of measuring impacts of adaptation efforts. So welcome and take us through the discussion today. Thank you.
Okay, thank you, Damaris, and thank you everybody else for attending this tea time talk, African Studies. This is one of the two main lines of talks. The other one is focus on Africa, but we take every opportunity over there to fill in, to bring in more talks as well, more presenters. So I am in the Department of Geography, Environment, and Spatial Sciences. So I am originally from Malawi. So I have a background both in the social and the natural sciences. So my main interest is really at the interface between the social and the natural. So a lot of the work that I do is based on that. So it's like my training is like my first degree is in ecological sciences, like with honors in forestry, and I gravitated a little bit towards geography. And it took me a while to, I went through an identity crisis when it wasn't internal, but if I was to mark myself in terms of what field I was in, it took me a while to consider myself a geographer after I'd come in from the natural sciences. So, but then I did for my master's GIS and international development, and then for my PhD at Illinois, and then looked at human geography, looking at community-based natural resources management. So, but what's important as well is that this is like my second life. In my first life, I worked for the government in Malawi and then doing forestry management, social forestry. And I worked for the Southern Africa Development Community doing forestry sector technical coordination work. And I also did a stint coordinating biodiversity conservation for the Southern Africa Development Community. So this informs how I approach my research, and that I'm very much grounded in the problem solving side of things and finding solutions, always integrating what I'm looking at in the context of international diversity. For me, at the end of the day, is the human well-being and the livelihoods. And I do all my research, pretty much all my research in Africa. So mostly Malawi and other parts of mostly Southern Africa. So I think that's enough of me for now. Yeah, but I'm interested to present this work. So everybody else will come at the end or now, the introductions?
Actually, we are not going to introduce everybody.
Okay.
But when their time comes to comment or ask a question, they can feel free to introduce themselves. Thank you.
Okay. So this is the and then this work this presentation here is almost bifurcated. It's almost like there's two parts, because when Damaris asked me to talk about climate change in Africa, and I thought that I had done this before, and I thought that I would give an overview of some of the issues, what are the impacts, the potential impacts on climate change. But then I wanted to move on to new work that I'm doing now, looking at measurement of climate change adaptation. So that part of the work is still work in progress. And so that's why I'm saying that this work, this presentation will almost look like there's a split in the middle, but the first part is really just an overview of climate change adaptation in Africa and some of the challenges. And then to kind of move on from there to consider how some of the major issues that the international community, especially the least developed countries that that have a lot of the burden on adapting to climate change, what are some of the major issues that they have to grapple with? So that the introduction there, some stuff on projections of climate change, adaptation responses, some of the things that are happening. And because adaptation responses and all that, they can be very broad. They come in every sector of the economy, of the social and economic sector. They go to infrastructure, transportation, biodiversity, health, and environment, and all that. And so I'm kind of focusing as an illustration just on food security, what some of the impacts on food security in Africa might be. And then I'll just move on to talking about measuring impacts of adaptation to climate change. And in this case, just to focus on the challenges and looking at the some of the literature that we are looking at, and then introduce a project that we are working on to try to grapple, to explore these ideas about measuring impacts of adaptation to climate change. So, and then in terms of challenges, I'm mostly interested in the work that we are doing and how we can move forward. So this is the structure then. So, and introduction here. And so again, just to remember, just go back to the population a little bit. Africa's population rising very rapidly. And so food demand, demand for food, fuel, and other ecosystem services that we get for the environment is increasing very rapidly. And then you also have, and I need to, I'm trying to hide this thing, it's blocking my view. So you can see some charts here showing this population growth. So Africa, we're pretty much at 1.4 billion people now, so 16.7% of the global population. But for the 21st century, Africa is really where a lot of the population dynamics are happening, rapidly urbanizing. So the next largest group of people coming into the middle class will be coming from the African continent, lots of young people. So lots of challenges in terms of getting everybody employed and educated and social services, but also an opportunity to take advantage of the youth creativity, the energy and creativity of the young people. So very young, the median age, 19.7% still. Very rural still, 56%, but population rapid reaching 2.5 billion by 2050. 2050 is not too far off. I don't know, maybe some of us will still not be around, but there's a lot of young people here who will. But so that would be, so you can imagine it would go from 16.7% of the global population to more than a quarter. So every 1 in 4 people in 2050 will be African. So those are huge changes that are happening. So when we are talking, so it's important to remember that as we are talking about climate change and some of the challenges that are likely to come, but also the opportunities. But food security and insecurity is really a major challenge there. And so, and again, just remember the background where we are starting from. This is the climatic zones across the African continent. And as see up here, Sahara Desert is light brown. These are dry areas already. And then you have the tropical rainforest, of course, and then the humid tropical climate. And that's the thing about the African continent. It's almost split equally in half across by the equator. So the climate, it's almost like the flip as we look at the northern and the southern hemisphere. And as we are the Sahel, as we are going further up, this is semi-arid. So if you are talking about areas that are like, reasonable amount of rainfall, it's really a lot of it is in here, the savanna and then the tropics. But you can see a large part of the African continent is already arid or semi-arid, so more than 50%. So huge climatic contrast to start with already. And you already have about 8% Africa being in tropical climate. And you have arid lands, areas that are formally identified as arid lands, about 1/3. And so this is where we are starting from. So I just kind of just try to highlight the food systems and food insecurity as a key priority because, it's life, right? And a lot of African countries in the least developed countries, now food is the biggest priority. So I'm just using food as an example of the impact of climate change and then the need for our food systems and agriculture to adapt. So these agri-food systems, they're not just providing food, but they give us healthy diets to most of the people on the African continent, but they also reflect a high disease burden that is associated with poor nutrition, food insecurity, malnutrition, undernutrition, and then challenges that are associated with that. So just looking at that one part, one aspect of society and then how climate change would stress it. So 256, about 20% of Africa remained hungry in 2018. And then you have Northern Africa, 17 million, Sub-Saharan Africa, a lot more people, about 240 million. So 3 in 4 Africans at that time could not afford a healthy diet. And then you have an energy sufficient diet. You have most people cannot afford it. You have 1 in every 10 people that are taking an energy sufficient diet. So looking globally, you have 185.5 million people that cannot afford energy sufficient diets, but 80% of them live in Africa. I just want to kind of frame this as some of the background that we are going into. There will be other elements, the economy as well is parts of some aspects of the challenges as well. So just looking at projections of climate change, so I have relied heavily here on the Intergovernmental Panel on Climate Change, IPCC, and their latest report, the climate change report, the AR number 6, their 6th report, which came out in 2021. So looking at the African continent, these are the major things. And what we are saying is that a lot of changes in climate have already been observed. And then even more drastic changes are projected into the future. So these are some of the things that have already been observed. So surface temperatures have already increased by 0.5 to 2 degrees. Looking back the past 100 years, you have these increases have been more rapid in Africa than in other regions of the world, and now they are shown to be mostly caused by human activities. And then you have increases in the number and intensity of hot extremes, so heat waves and challenges like that. But then there's also the decreases in cold extremes. So cold waves are decreasing. You know, there are some parts of Africa, mostly the highland areas, that might have these problems. So on the oceans, you have heat waves that have become more frequent. So this is also associated with lots of hurricanes. For example, there's been lots of in Southern Africa, the Idai, and causing a lot of havoc on the Southern African part. So sea level also increasing, although a lot of the coastal areas in Africa are fairly the kind of escarpment, but there's some very low-lying areas that are not as widespread on the African continent, but yeah, an increase that is higher than the global mean still over the last 3 decades. So this maps showing 1901. These large pixels, because these climate models are fairly coarse in what they project, but it can show you the changes in temperature across Africa and what has been happening. And so just to delve a little more in different parts of the African continent. So when you look at the West Africa region over here, so the challenges increases in flooding, increases in drying, and so agricultural land they're subjected to reduce productivity because of droughts, ecological droughts. When you look at the Central Africa region here, what we have, mean precipitation will decrease. Remember that quite a bit of that part, when we looked at the climate map, is in the tropical climate area or the humid. So a decrease in precipitation there will be quite a big deal. So standardized precipitation is declining as well. That means that the declines are real in terms of statistically. So agricultural and ecological droughts are increasing there. Looking at the West Southern Africa part, that's how they mark it down here. So temperatures decreasing, you have more incidences of heavy precipitation and flooding. And then you have areas becoming drier and agriculture and ecological challenges being increasing. So if you look at the West Monsoon area, which is way down, this is all the way down here. So the western side, but getting onto the Indian Ocean. So monsoon precipitation is going to increase in these areas due to warming. So not everywhere are you getting a decrease in precipitation. So already the increases since the 1980s that are partly due to the influence of greenhouse gases and then the cooling effect. And when you go all the way up to the north, it's already, a lot of it is already dry, so it's going to get worse, increasing in aridity. You have droughts, both hydrological droughts and agricultural droughts. Hydrological ones is just total shortage of water, and agricultural droughts is shortage of water that's needed for growing crops at the times when the water is needed and in the quantities that the water is needed. And so, and then, so what we looked at before here, so this is what has already been observed, right, in the different regions of Africa. Yeah. And we're still continuing that the Northeast, we're going into this region now. Again, precipitation goes down. This is where Kilimanjaro is, the glaciers are declining as well. I keep hearing about that on the public radio station when I'm coming here to work. And then you have Southeastern Africa, again, the decline in glaciers here. We have Kilimanjaro, Mount Kenya, Mount Meru in those places. And then also floods, the same story, ecological droughts. And so for a lot of the Africa, droughts and floods increasing, one of the major challenges is a common challenge that's being faced. So, but if with a 1.5 degree increase in temperature, then these projected droughts and changes are even going to be worse. So Madagascar is going to be more dry, and I guess so that will be a challenge for that huge island. So again, so these projections is really the IPCC is becoming alarmist. I mean, they're becoming more urgent to get action from the global leaders. So like unless there's immediate and rapid and large scale reductions in greenhouse gas emissions, bringing it down to 1.5, a lot of these potential solutions will be beyond reach. Lately, I've kind of heard that people are giving up on the possibility that we're going to maintain our temperatures within 1.5 degrees already. So they're trying to say, okay, so even if we exceed 1.5 degrees, what can we still do? So the climate change, the Conference of the Parties, the next climate change conference is happening from the beginning of next week. It's going to be Egypt. So people are gathering there as well after Glasgow. Let's hope that we'll come up with solutions. So again, Africa remains the most vulnerable world region to climate change, and food insecurity is really a huge one of those key major challenges. So we talked about these hot extremes. So now we are, this is projected going into the future. Sea level, the same problems that we talked about, frequency and intensity of precipitation happening. And there's been an example, we were doing a project in Malawi, looking at comparing the Great Lakes of Malawi and the Great Lakes of here with people from the University of in Minnesota. And one of the professors there has been tracking rainfall patterns in Malawi. And there was, in 1 year, there was one big rain event that on which 35% of the total annual rainfall fell in 1 day. And so those are the kinds of things. So if all this rain dumps down, of course, there's problems with flooding and soil erosion and crop damage and property damage. But that also means that when you need this water to water your crop over an extended period of time, you likely will not have sufficient rainfall left over. So this frequency and intensity of these heavy downpours is really some of the major challenges. A lot of the southern and parts of Africa, it's not so much that the total amount of rainfall is declining, it's just the patterns that are changing. So the seasons, the rainy seasons are generally shifting. I think in Malawi, at least 1 month later, so rain is starting later. But it tends to stop sometimes earlier. So you're having problems to have crops mature with enough moisture during the growing season. So, and again, so in terms of temperature, these maps kind of show the changes in precipitation here and in terms of projections. But if you go from 2001 to 2020, just look at the southern parts of Africa here, these shortages here, the declines, but they intensify by the time you go to 2041 to 2060. And by 2081 to 2100, this is a huge hotspot of very hot and very high increases in temperature. And then there's that part in Northern Africa where you have other challenges in declines in precipitation. There are some locations, mostly it's in the highland areas, where precipitation will actually increase over this time period. So, so the kind of gray areas here, there's areas where they are looking at per capita water consumption will exceeds the indicated thresholds. But then in a lot of these red areas, you're way below what the consumption should be. At the same time, there's a kind of thing they call the East African rainfall paradox. So it's something that puzzles scientists, that although climate models that predict a lot of precipitation increases, when you go on the ground, precipitation actually decreases, and then you also have a shorter rainy season. So scientists are still trying to find out what the challenge is. Sometimes it's, you know, it's just a dividing line where the boundaries between models, different models, they don't really overlap that well. There's some boundary areas where the predictions aren't as good as in other parts of the world. So that might be something like that. So in terms of projected changes, I'm not going to go into detail here, but it's the same things. Okay, wind speeds are increasing in all regions of the world, drought and floods, right? Drought and floods here, down in the southwest, in the Indian Ocean, the danger with the monsoon now, floods like the Idai might be, hurricanes will increase, and then it's even drier up in the Mediterranean, as we saw in that image. And the Sahara already drying, so danger of expanding desertification in those areas. And but in northeastern Africa, there's increases in heavy precipitation there as well, and flooding. And the same challenges in Southern Africa. One of the challenges is sometimes you would have a drought, and then the following year you have floods. Or sometimes in the same country, you have one part of the country is in drought and another part of the country is experiencing flooding. So these are lots of variation across space. So the East Africa regions, again, so we're looking at a 1.5 degree increase in temperature, where you're having these challenges of increasing drought and extreme events. So, and then Madagascar, the same thing. So, and Madagascar, you know, there's a lot of biodiversity there. It's one of the richest biodiversity around the world. So if these temperatures increase faster than the biodiversity can adapt, there's also a challenge that you would lose quite a lot of biodiversity. And tropical cyclone challenges there in terms of wind speeds as well is some of what they are projecting over there. Just showing some maps here, annual maximum precipitation on the left columns here. So if temperature increases by 1.5 degrees, and then this is compared to 1851 to 1900. This is 2 degrees, and this is 4 degrees. So we definitely don't want to be, we don't want to allow our temperature to increase by 4 degrees. The whole of Africa would be like some hidden, some oven place. But notice how the annual precipitation and the annual maximum precipitation, there are some parts of that. So the green part is where rainfall is actually increasing, and then the brown is decreasing. And so, and then these are the increases in temperatures. So all of Africa, if we have 0.4 degree, 4 degrees centigrade increase, pretty much most of Africa will increase will go up to 4 and 5 degrees. So huge challenges there. So, and then coming back to this example of food security, then, so what we have already observed changing in the climate is already messing up a lot of things. So then to think about these projected future changes is really a huge challenge that the leaders and countries must do something and to try to adapt, even as efforts to reduce these greenhouse gas emissions in terms for mitigation. So mitigation is you're reducing the greenhouse gases so that you slow down the warming of the earth, and adapting is, you're taking measures to still cope in the context of climate change. So a reduction in food availability is projected. Fish and animal health will decline. Yields are declining. Corn, which is really a dominant grain and staple food for a lot of Southern and Eastern Africa, wheat, sorghum, and fruits as well. So you have reduced yields all the way up to the Mediterranean. Dryland areas, they were already marginal in terms of productivity, but food insecurity is a big challenge there, though people are using their indigenous knowledge to try to adapt to these changes. So some increases in terms of maize, just in higher latitude areas where rainfall is also projected to increase. So it's not all dire, but for most of the continent, then things are, maize production is coming down. Part of the reason is just carbon dioxide fertilization. As you get more carbon dioxide in places where conditions are already good, you already have a lot of temperature. You have high temperature and you have a lot of moisture. Then the process of photosynthesis and can take advantage of the increased CO2 to produce more food. So some of these direct impacts of food, so reduced water availability, production losses, 22% decline in maize for specific crops, sorghum 17% and millet 18%. You have groundnuts and cassava 8% declines. And then we're moving on. By 2050, per person food availability declining by 3.2%, and then accessibility to food also declining. And then you have also direct impacts that are happening in terms of natural resources management in general. Pastoral systems will suffer as well. So livestock heat will reduce breeding in animals and productivity for milk and meat as well. Pest disease distribution changes, mostly pests and diseases spread in range. And then extreme events will also undermine food production, because in places where sometimes the flood happened during the rainy season, when the crop is almost ready and the crops get flooded and washed away, and you get total loss of your yield. So food prices increasing, we're already seeing some of that even before this war that's happening in Ukraine. And then you have smallholder farmers, again, particularly being affected. A lot of them are subsistence, so now having to rely on to go out and buy food. So this is one of the projections looking at grain, projected cereal production in Africa. So where this beige kind of color is like almost standard. There's no change in terms of projected production up to 2080 in terms of cereal output. There's some areas where grain production actually increases. This is some of the areas where rainfall is projected to increase. But there are also very vulnerable areas. You can see that a lot of these are on the edges of the Kalahari, so in areas that were already dry. The largest decreases of up to 50% decline. So this is extreme declines. And then the oranges are areas where quite a lot of declining is happening. So just some examples here. There's food insecurity in terms of floods in Sudan. You had 100-year flood, 3.5 million people displaced in 2020 and without food. Southern Africa, You have lockout surges in East Africa, several countries that are messing up. So again, also being linked to nutrition challenges, undernutrition, and especially among children. You can see the number of undernourished people has been increasing. So up to 250 million over here. But the prevalence is kind of more like stabilizing. So this is just some images here showing the flooding in Sudan. This is just some examples here, and the kinds of just show the kinds of damage: 33,000 hectares of farmland, and so many houses, and so many people moved. But this is some of the impacts of climate change. There are also some indirect impacts. So 75 to 250 million people at greater risk of water stress. And as we are moving by 2020 already, but as we are moving to 2050, this number increases and is more than doubles. And then, so arid areas in Africa would increase. And remember how I started with that map that shows more than 50% of Africa is already arid or semi-arid. So challenges of water continued, and then you have some hidden health challenges because there are burdens as we are thinking about food production, damage to the environment. That's not really usually taken into account when we are looking at the negative impacts of climate change and environmental degradation. So if we look at food production now, this is food consumption patterns is that you would add about 35 cents per dollar that would be spent on food in sub-Saharan Africa, which is like 26% of the total cost. So you're increasing the cost of food. And then when you look at it globally, 21 to 37% of total greenhouse gas emissions are attributable to the production of food. So we're not only producing food, but in producing food, we are messing up the environment and contributing to global warming. So, and then there's also gender dimensions, other social dimensions to food security, insecurity. In a lot of African countries, women still the major producers of food. And so a shortage of food increases burdens on them and disproportionate burdens on them and other challenges of inequity. In terms, just looking at water availability projections to 2025 compared to 2020, this map here, 1990 versus 2025, you can see huge declines in water. Cote d'Ivoire almost more than half. If you just draw this line here, a lot of these countries up here will have declines of more than half. Even these sets of countries here, you have water availability and water scarcity increasing. So, less than the amount of water available being stressed. So these places in North Africa, of course, they're already semi-arid. There'll be huge scarcity there, but these countries there will increase in terms of the levels of stress. So these are some of the challenges. So this is what I meant when I said the first part is kind of looking at this thing broadly and to just look at the contents of climate change and challenges on the African continent using the case of food insecurity as a challenge. So now I will move to the next part. And with all these challenges of climate change impact and the need to adapt, and now actually more resources being available. In fact, one of the challenges on the African continent is that a lot of African countries are not, submitting project proposals enough of sufficient size to use up money on the climate fund, where the target was to get to 50 billion to $100 billion annually. So the challenge is not so much that the money is not there, for adaptation. The challenge is that the countries are not moving in the LDCs are not moving fast enough to take advantage of it. So, so looking at that in terms of managing adaptation, and you're taking in this global governance systems for managing climate change, which is mostly the United Nations Framework Convention on Climate Change, UNFCCC. So you have many countries that have really been working to integrate adaptation, not just in specific projects, but countries now are integrating adaptation planning into their development planning, because now they see the threat of climate change as being a stressor on development in total. So whatever development, there isn't a sector that will be left untouched with these impacts of climate change. So then it has to be a factor whenever you're doing development planning, how you can adapt, and then how you're gonna grow your economy on a low carbon trajectory. So you're reducing your footprint in terms of carbon emissions. Let me just go back here. So in terms of some of these initiatives that are organized and coordinated under the UNFCCC, and I'm mostly interested here in the least developed countries, the LDCs. So you have the national climate change and response strategies and policies that countries are they're developing on themselves, partly because of efforts that were done before, for instance, National Adaptation Plans of Actions. So countries that were in the least developed regions of the world, these were called, and they're called Annex 2 countries in UNFCCC lingo, and the industrialized North and the kind of emerging economies are like the Annex 1 countries. So now we have moved from making the National Adaptation Plans of Actions, which were trying to address immediate and urgent needs. Now we are moving to national adaptation plans. So to start developing significant projects to adapt to climate change, not just tiny little things that are just planning. Now you're moving into implementation. And the progress is still a little slow there. And there are still a lot of countries that haven't develop their national adaptation plans, which is a mechanism for them really to go and access all that money in the Green Climate Fund that's being put there. So, and also these nationally determined commitments, NDCs, this is where mechanisms that African countries are using to deal with to structure their efforts to adapt to climate change, to mobilize resources and move forward. So these global governance commitments from the UNFCCC are really a good part of that. So there's also sustainable development goal number 13, take urgent action to combat climate change and its impacts. So this has 5 target areas and 8 indicators that are involved in that they're trying to track there. And you know, the explanation for SDG 13, they claim that climate change is the single biggest threat to development around the world, mostly in the least developed countries and including Africa. So these are some of the targets they are looking at: resilience and adaptive capacity strengthening, and integrating climate change measures in policy, building knowledge and capacity to meet climate change, and then implementing the UN Framework Convention on Climate Change goal of mobilizing $100 billion annually by 2020, mobilized by the industrialized nation, targeted to the least developed countries and their adaptation needs. So they are not there yet, but they are moving there. The thing is not, the pace is not the problem now, it's the absorption capacity of least developed countries to use the money that's there. So we hope that there will be more pledges in the next 2 weeks when the people meet again, the next conference of the party in Egypt. Here, I didn't want, and I'm just trying to show this as how complex, to just show that adaptation is really a complex thing. There's so many dimensions. And if it's something this complex, then measuring it also comes with lots of challenges. So this is just an example of food systems, right? You have food systems in the center. So you have crops and livestock and fish, aquaculture. You have processing here, value chains and markets. And then you have demand side of things. You have lost waste of food. But then look at all these other components that come into that. So you have emissions and impacts affecting food, and you have adaptation in here, you have mitigation using agriculture to reduce emissions, and then going ecosystems, and you have impacts interacting. So we have ecosystems, land, biodiversity, soil, water, and you have outputs here, moving on to human well-being, and then socio-economic system here. So there's a social system, economic system, natural systems. These are, and then the climate at the top. So it's very complex. So then measuring the impacts of adaptation measures, that it makes it even quite complicated. So these are just examples of pitfalls to measuring climate change adaptation, kind of just looking quickly in the literature. You have, so in terms of measures, metrics of adaptation impact, the main purposes for doing these measures and impacts are mainly here on the left-hand side. So you want to identify adaptation needs and to define what successful adaptation is. This, in our little project, and we're going to introduce it, just defining what successful adaptation is a challenging thing. So, and what does it mean to different people? Well, how do you know that you are successfully adapted, right? So it's not a very simple question. And then the other part, you want to track adaptation actions. So you're keeping tags, and you're especially interested in how they build up. And then you're assessing adaptation results, which is where we kind of centered in the little project we are doing. But the purpose is to then be able to guide the allocation of resources. But then, and then when you do that, and then to be able to track what the aggregate of the adaptation processes is. So this is, there's some work that's being done by different groups looking at and how to address this challenge of adaptation. So one of the big questions then is, can we measure, aggregate, and compare climate change adaptation needs and results, not only across activities, but also across countries and sectors? Because if we cannot, then we are left with the challenge of having to measure a lot of these elements separately. Right? And that's a lot of measurement that would be needed to do that. Yeah. But is there a way that you can aggregate some of these measures of impact so you don't have to go and measure each individual intervention and impact in a complicated setting like this? And this is just food security. There's transportation, there's ecosystems, there's disasters and preparedness and all that. So some of the challenges in the first part in identifying these needs and defining them, there's no single objective, right, for what adaptation is. So you can't determine what the needs are universally. You got to look at the context. So then seeking metrics, then even just starting to look for measures, metrics, then you run the risk already that you are overlooking something that's important. And some conceptual insights as well. In terms of tracking adaptation actions, it's not as straightforward as you think. There are many actions that are happening and things that you might not think of as adaptation, but in the end of the day, they contribute to adaptation that would be left out. in terms of assessing adaptation results. So again, if there's no single metric or measures that can be, that you can use to simultaneously kind of fulfill the same, be measuring the same thing, adaptation purposes, and that if you don't have those, then assessing adaptation results becomes a huge challenge. And then we faced this, and then we went to Malawi to start looking at how people perceive what their adaptation needs for Malawi are, how they are perceived, and how they have been thinking about measuring adaptation impacts. And this is some of the challenges that we have to grapple with. In terms of guiding of allocation of natural resources, a lot of us have been engaged in the policy process. It's usually not the science that drives where the money goes. It's usually some value judgments that people make. So if you use the amount of money put into adaptation as a measure of impact, then you are missing, you'll be missing a lot there as well. So then there's the process of tracking and aggregation, and how much is spent can be misleading in that sense as well. So, but some lessons that have been learned, and as in terms of in some areas and some limited projects at national level and subnational levels in trying to measure adaptation, is the importance of maintaining a clear picture of what the desired changes and outcomes are. Because if you don't have those set out right at the beginning, then it complicates what you can measure. And you have to be able to show causal pathways in which to achieve those changes. So so change indicators and metrics, you have to adapt them to local realities. The same indicators can be capturing different things, different dynamics in different settings in different countries. So it's very location specific, which is then one of the major challenges, is how can you get indicators that are broad enough to avoid having to go measure every little things, but at the same time capture some of these local contexts. So stakeholder engagement is critical. Participatory discussions on metrics, what to use, and in part for ownership of adaptation activities. So if the people that are implementing these adaptation interventions are involved in the process of devising what measures of impact are, then it's easier for them to be part of the process then of tracking and measuring and providing information about impact of adaptation. Just to go back to an evolution here of in the United Nations Framework Convention on Climate Change, somehow they have been thinking about adaptation and measure. It's important to look at the scales on the left-hand side. As geographers, with scale is a very important concept. Where's a reasonable place to measure? Is at a local project level, national level, global level, or of a higher level? So this project that we're doing, we're interested mostly at the national and subnational levels. So looking at milestones in terms of discussions, decisions made by the UNFCCC in the Conference of the Parties. You go back to like 2001, when you had the LDC fund. It was essentially criteria to qualify for funding from these, the LDC fund, the adaptation fund. So you had to show some criteria about impact, right? And then moving results-based management, funds accounting, so metrics to monitor and evaluate adaptation actions. So they were coming in directly. And then you're coming in 2015, the Paris Agreement is now becoming more deliberate about measuring impacts. So metrics to evaluate collective adaptation progress. So that by 2013, and this is another thing that we hope some of this work will contribute to, is that by 2023, next year, there's the global stocktake is supposed to take place about all these efforts on adaptation, what is going to happen, what has been the effectiveness. And the methods for doing that haven't really been developed sufficiently. So, and now the potential adaptation actions, just to give a sampling of adaptation impacts, indigenous knowledge, like if you look in the Sahel, these features that farmers make to conserve water, right? So how do you measure the impacts of that if you are going to a lower level of individual farmers and their adaptation actions, right? And you have ethnoclimatology, this deep knowledge that people have of the weather and the climate and how to live within its limits. And you have farmers in Niger. These are examples of adaptation again. They are doing replanting trees, using natural regeneration, and then some of their land productivity is coming back. Crops are increasing again. Morocco, there's a kind of green revolution, more mechanized, just a variety of things that are happening. And some of the things you can do in agriculture, but the diagram on the right is kind of looking at climate change adaptation from the risk perspective. It's a risk that you need to deal with. So the risk and potential for adaptation. So you are looking at temperature, extreme temperatures, and different time scales, a time frame. So that, like at present, so the risk and potential for adaptation remains very low, right? But in the near term, 20 to 2040, people will start, it becomes more in the medium term, but as temperature increases in the longer term, 2080 to 2100 to 2 degrees and all that, then that risk becomes higher. So this on the left is some of those impacts, some things that people do to adapt, diversifying crop system, access to land and credit, so people have access to productive resources, improving governance. So adaptation then is essentially about risk management. So I'll just skip this slide here and then kind of start looking, just introduce this project because it's work in progress. I'm going to just spend maybe about 5 minutes on this just to introduce it. It's still work that's going on. So exploring adaptation impacts and measurement in Malawi then using satellite data, right? So this is we call this project, we call it Geo for NAPs, right? And so there's it's not a large project. So this the team here. Here at the MSU, we have Dr. Alison Lassiter from the UPenn, Dr. Sosten Chiwata in Malawi, Leadership for Environment. We have David Stevens, is an independent researcher in Geneva, but he retired. He used to work in the disaster preparedness unit of the United Nations. And then there's Dr. Paul Disanka, who's at the UNFCCC Secretariat in Bonn in Germany. But he's more of he's more in an advisory capacity because he can't participate actively in these things. So then bringing this challenge of measurement of adaptation down to the ground now within the national adaptation planning processes of the United Nations Framework Convention on Climate Change is that recognizing those efforts, increasing efforts to climate change adaptation that are happening. But how are you going to know how well you are doing? First, there's a need now to start measuring impact. But then within the UNFCCC system, there isn't a formal mechanism to provide objective assessments of impact. Adaptation, according to the UNFCCC system, is what each country member says it is. So if they say in their report, as they report, that we are adapting to climate change, then you can't go and say you're not, or you can't argue that they are not. So it's essentially, it's self-reporting. So it's important to find an independent way that's not too costly, but it's also repeatable across countries to try to measure impacts of adaptation so that you are not dependent on what countries are reporting, but you are, you can compare across countries and you have a sense of what's happening. At the same time, you are also using this process to take it through the national planning processes so that impact assessment is being built into national adaptation plans that are being created moving forward. So what happens now is that impact is mostly measured by how much you put in, right? It's based on inputs. Now, but we know about, about lots of things. And it's not how much you eat that will make you fat, right? It's how much you digest and take in that will do that. Now, some people will eat tons and tons of stuff, but they have amazing digestive systems. So it's the same thing. It's just because you put inputs in there doesn't mean they'll produce the results you want. And then some of them are just based on processes. So you're just measuring and that process, you are monitoring and measuring processes. And so a lot of them are just performative. Yeah? So inputs, how much funding is provided, right? A number of projects that are funded and implemented, and process, the degree of mainstreaming of climate change. So are you doing adaptation planning, or how many sectors have a plan? This is kind of process indicators. And so, and then performative things. So it's like you get a grant, where as part of the requirements of the grant, there's some indicators you have to report. So a report is produced. So some of that is performative in the sense that the end is not really to really understand the impact, but you just want to meet some intermediate ends. So then it's really important because sometimes the desired outcomes is another challenge, or the definition of what it means to be adapted, that's not very clear as well. So these are some of the challenges that we come into in this work. So a lot of the work then looking at impact, measuring impacts of adaptation still in the early stages, although there are some teams that are trying this. And from the UNFCCC process and the National Adaptation Plans process, it has been frustrating for them because of the dependence on self-reporting. So some people are reporting this through sustainable development goals and they are monitoring and evaluation, but it's all piecemeal. So then there's the, how about harnessing the potential of, big data? Here we're talking about satellite data that are available, readily available. In this particular case, you have the Microsoft planetary computer that they have provided space and lots of data available for people that are working on the environment. So you want to go beyond these traditional just measures of vulnerability and just risk assessment to understand what's happening and the impact, so you can inform decision making. So, and at the end of the day, you want to be able, this would lead in the end to monitoring systems, so direct measures of impact and adaptation. And sometimes that's one other thing is you can't measure adaptation directly. Sometimes you have to think about resilience to climate change, or and how to what do you need to do in order to, if a climate change shock happens, how quickly do you recover is what resilience is trying to measure. So just these same challenges on the Malawi context, a lot is similar to a lot of African countries. So lots of challenges, very much dependent on agriculture, food security and the economy, big problems in terms of poverty, like very rural population for Malawi, just $642 per person per year is the gross domestic product for everybody. So that you have lots of people that live below the poverty line. I forgot a comma here, like 70.1% of the people live below a poverty line of $2.15 per day. So this is a context that you have to think about these adaptation measures. Heavy dependence on agriculture. So if you, for Malawi, 40% of all the export value comes from tobacco, just one single crop. Then other crops, you have tea, cotton, sugar, and legumes. And then you have, so also lots of environmental challenges, deforestation, biodiversity loss, soil erosion, fisheries decline. A lot of these have been estimated to cost the economy. The cost of environmental degradation is about 6.8% of GDP that's being lost. So, and also another challenge, very heavy dependence on solid biomass fuels for cooking. So the pressure on forest resources and biodiversity. So some of the things that they are doing, just an example of flooding as well for Malawi. And this is a lot of the situation for a lot of countries. So Malawi contributes hardly anything to global warming gases, 0.1 tons of carbon dioxide emissions per person. That's hardly anything, right? But then they suffer the impacts, the negative impacts. Just looking at floods, increasing frequency of floods and droughts, just looking at the last 5 years, right? So in 2015, floods happened, causing losses of about $335. The following year, you have a drought in 2016. You have $365 in losses. And the economy is messed up and poverty is worsened. The poverty rate increases by 1%. And in 2019, you have Cyclone Idai comes again, causing lots of physical damage and more damage. So these are the kind of challenges, the frequency of these extreme events. So in terms of the priorities that they are following in Malawi, then you have formulation of this National Adaptation Plan. They are in the process of doing that. They are focusing on developing these and implementing projects and programs. So one of the things they are looking at is to develop a national climate index and climate information systems, and then looking at multiple hazards, early warning systems. And so monitoring, active monitoring systems for different things, crop yields, water, ecosystems, and all those kinds of things. But also to start thinking about supply chain dynamics for key commodities. So in the end, you're monitoring crops, but then there's a plan to integrate this into a global monitoring and a model crop monitoring that's called GeoGlam from the University of Maryland. And then lots of cross-cutting projects that are really respect how complex adaptation problems are. So you're including infrastructure, early warning, ecosystem-based adaptation, locally led adaptation, climate information services, and research. So these are all the things that were in here. So then to this now, the big introduction, and so I will just very quickly look at this project that we were talking about, that we started, and we're just at the very early stages. So we want to use the best available spatial data and methods from different sources and to inform the development of high quality data-informed national adaptation plans, and then measurements of impacts of adaptation outcomes. So this is like at the end, that's the purpose. So you're integrating it within national adaptation plans. At the end of the day, you want to measure. So we're exploring different ways to do this. So these geospatial and socioeconomic data, right? The interdisciplinary methods. And then we're also trying to look at, to develop a framework to pull this together. How far did I go? But in the context of least developed countries, and we are using Malawi as a case study. So we're starting with Malawi, and we're trying to see how much of this, if we use this data for Malawi, then can we use the same methods to extend to selected countries, right? And if we can't, what are like the minimum generic data that you would need, and what supplemental local data would you need to do those kinds of things? So this is a small project that is the Geo for NAPs. GEO stands for Earth Observations Group on Earth Observations. So it's just their name. And National Adaptation Plans is NAPS. So this is a program under the GEO Microsoft Planetary Computer Credits Program. You know, it's funded. So Microsoft funded the GEO to implement this project, and they work with the World Meteorological Society. So this project is really just a small project. It's just 60,000 in money, and then you have 60,000 in Microsoft credits. In terms of Microsoft Azure credits and modeling stuff, to use their resources and data and big data stuff that you can use. So just 1 year, and it's been slow to take off because of all these challenges, but it's supposed to start in May. It actually started later. So the overarching question, can we measure successful climate adaptation through readily available remotely assessed data products? And can these measures of climate change adaptation then be applicable across activities, sectors, and countries among the least developed countries? So this is kind of more broken down now. So the more specific objectives: advanced vulnerability and risk assessment as part of national adaptation plans, measuring adaptation outcomes. The key interest is that independent of self-reporting by countries. This is what we want to. We want to avoid that subjective process, and to find a process that's more objective. And then awareness and capacity building. Once we've done this, and what data are available and what they can be used under GEO, the planetary Microsoft planetary computer, and then contribute to coordinated role and kind of technical capacity building of the least developed countries experts group. It works within the UNF system. So that would be like a channel for us once we've tried some things to see, to think about scaling up. So some of the activities that are being implemented now, just I think a couple of slides more from here. So identifying these core sets of indicators, and that has been going on for a long time. That tried for quite a bit now. That can capture adaptation in an aggregate way. We don't want to be. It'll be too costly to go and try to look at individual measures. But then they have to be information that can be captured with satellite data. So we are looking at indicators broadly, and then seeing, okay, how can we get these key indicators, just a subset of small number that we can get the measures from satellite data. So literature reviews, and we can RA and helping to do that, a couple of RAs, and geospatial data downloads, one of them from the Microsoft computer, and building a database of what we already know, what we already think are the key indicators from the literature. And then a visit and consultation meetings in Malawi. We did that over the summer. So we went to Malawi, we had meetings, consultations with the National Adaptation Team for Malawi, local experts, and we had meetings with the university experts there, and visited some of the major projects that they identify as adaptation projects, to understand what the climate risks are on the ground, and what the needs, what the interventions are, and what indicators are they thinking about already. So we're looking at the literature, we are looking at what people think locally, and then we are moving to a stage where we are integrating how much can we capture of both the local and what the literature says about this. And then we'll be moving on to the next stage for applying these indicators to measure adaptation. So kind of developing the integrative analytical methods, and then the literature review will informing some of that, and it's ongoing right now. And then we start disseminating and getting feedback as a combination of this. We already started talking about this. So one of our colleagues went to Glasgow, and they started, it was still an idea then, and then they are going to the COP in Egypt as well. So there's going to be a little side event, going to do another discussion, start getting feedback from people as well. So the scale and the measurement method, the scaling part, and the third stage will be to scaling up. What's scalable, and if it's scalable, what additional data would each country really need to collect to make this work within their own context? So, and then, so we've been narrowing down on the indicators. So some of the work in Malawi, you're processing a lot of the indicators that we collected and trying to make sense out of it. So this is the framework we are coming up with to really focus a little more narrowly on ecological health. We're interested in land and water, land and biodiversity will be the key areas we'll be interested in. And then on the human well-being side, we're interested in health, energy, and community stability. And so this will be the tool. We've having looked at the complexity of the problems, we think that if we go for these two, ecology and the human, so ecological system and the human systems, we should be able to capture indicators that capture a lot of these things. So we just started breaking some of these down now on the water, land, and biodiversity, surface water temperature, greening, and loss of. So then when you look at the indicators, there are tons and tons, you find lists and lists of indicators from different groups, but we are trying to look at what's relevant and what makes sense and from the interactions that we are getting. So health, energy, and economic stability. So, and then moving forward then, like I said, this is ongoing work. So the key thing is still in the form of questions now. It's the questions that we are grappling with. So what are the limits of these global data sets that we've pretty much already downloaded? And when do we require national level data, and what kind of data to really be able to do this? And then which aspects of adaptation can we measure or can be measured through these passive collected data products? So with the data products, what are we gonna miss? What are we missing, and what can we capture? And then which aspects then require we can identify additional needs. So in some aspects, we might need to be actively collecting data, of course, in a cost-effective way. So this is some of what we'll be grappling with. So, and then the approach in Malawi, can we scale that to LDC? And what would be needed to be able to do that? Or eventually will each country require their own measurement method? So this is, I will stop here. Like I said, it looks like two presentations, but I wanted a broader view on the African side, and because this continues, this is still ongoing work. I really just wanted to introduce it and open up for questions and discussion.
Okay, thank you so much, Dr. Zulu, for taking us through this very complex topic. Climate change, as we know, it's very complex because the world is a global problem and the world is interconnected. So sometimes you get to a point where you feel like, is it even doable? Because everybody has to take their role, to do their role in solving this problem. But it depends on the willingness of even the global regions of the world to be able to come together, and also it depends on, does everybody see it as a problem? Does it affect everybody equally? If it doesn't, what are the challenges then? So thank you so much, and for even focusing on Africa and taking us through what the impact is or has been and is continuing to be or projected to be. Also, what are the efforts to address the climate change challenge, and also the measuring the adaptation. There's some efforts to measure to curb this problem, but are we able to even measure the adaptation methods or efforts specifically that are being employed. So thank you for that. My question is, I remember you mentioned that there's increase in surface temperature, rapid increase in Africa especially, and then so that makes Africa the most vulnerable to climate change. And you also mentioned that this is caused, part of it actually, not everything, is caused by human activity. So what are the specific activities that you can mention that are particular to Africa or Malawi, if that's part of what you're doing research on? And also, are these human activity, or is these issues related to human activity being factored in the national adaptation planning processes? Thank you.
Yeah, thanks a lot, Damaris. So starting on the human activity, this is so I use the word anthropogenic. So it's more in terms of the human activities that produce the global warming gases, and then that's part of the injustice of climate change, because Africa plays a minimal role in contributing to the global gases. It's mostly the industrialized nations that are putting a lot of emissions. I mean, there's some countries in Africa, South Africa, Nigeria, and other countries that are more developed. But in terms of countries like Malawi, so they say about 30% of the global warming gases will come from deforestation and agricultural activities, land clearing and cutting down of trees and deforestation. So those would be the kinds of activities that would be happening in African countries, in Malawi, that mostly contribute to climate change. There's still industrial activity and the use of petroleum and all that, but for most countries, that's a much lower percentage of the contributors. So that's one of the things. So this is an example of like a global problem. Like we talk about the commons problem. So it's like the causes might happen somewhere else, but the problem affects everyone.
Yeah, thank you so much. Yes, because we share this space. As much as the world is interconnected, sometimes there's some challenges that you can address locally, for example, but the climate change one, or gas emissions, for example, is just the same space that everybody shares on Earth. So I see a question, and please feel free for those of us who are here to ask you a question or give a comment, but there's a question here by Isaac that says, how much is being done in Malawi and across the continent with the growing of crops that are drought resistant to help stem food shortages?
Okay, so that's thanks, Isaac. So that's really a common the agricultural service. So that's one of the good things, and a lot of our countries still have national research, agricultural research services that actually do good breeding work, crop breeding and all that. Now there are GMOs that are coming in as well. In Southern Africa, countries have been resistant to accept GMOs, but the resistance is chipping away, and some of that is happening. But that's one of the major focus on agriculture and food security. This drought-resistant crop. So maize that will mature in 3 months. There are cotton, and then even pigeon peas that is in Malawi, for instance. That's a new crop. The process that they are promoting for export to replace tobacco. So there's a drought-resistant one, and there's so that is a major direction that they are moving. So breeding different varieties that are resistant to drought. Some of them are resistant to pests and tolerant to drought. So so that's an important area in agriculture.
All right. Thank you so much. Any more questions from the audience? Yeah. It does look like Dr. Leo, you did a fantastic job in explaining all these concepts and for
No,
somebody like
it
me.
just means I ran on for too long.
No, we still have time. If somebody has a question, they can ask, but let's see. Okay, this is Isaac. All right. I mean,
Yeah, I see you won there. How are you doing?
actually, you may unshare your screen, Dr. Zulu.
Okay, yeah, sure. All right, stop sharing. Okay.
All right, thank you. You were saying hi to somebody on the screen.
Yeah, all this you won is a graduate student in my department.
Oh, okay.
I don't know, it might be muted.
Maybe it might be muted. So we will go ahead. I'm trying to be sure that I'm not closing any questions, closing out any questions in the chat. Yeah, hi Zulu, I'm good. So Yuan is responding to you. They're doing good. Thank you. And thank you for coming.
Right. Yeah, yes.
Thank you for coming as well. So I think we'll end it up here. And once again, thank you very much for, I mean, addressing, as I said, it's very complex when you try to think about a global problem that takes the global effort to address. As much as we're talking about Africa specifically, but still we're looking into what is happening internationally, as well as nationally or locally, as to address this problem. So we appreciate your time and we appreciate all the details that you've shared. And this recording is going to be shared on YouTube, and I'll share it with everybody else that may be interested. But if you can go to our African Studies website, just Google African Studies Center at MSU, you will find all the recordings from the previous sessions for this African Tea Time events, and also our Eye on Africa. I look forward to having everybody again back in, this is next week. Usually we do African Tea Times in bi-weekly, but we're having one because of the upcoming Thanksgiving, plus most of our members are traveling. So we're having another tea time next week, and I look forward to seeing you there. We'll be talking about youth entrepreneurship and community development in Uganda. So I will say bye-bye, and thanks again for everyone for staying with us until the end.
Yeah. All right, thanks a lot, Damaris, for coordinating this.
Thank you.
And thanks everyone for attending.
Yes.
Okay.
Bye.
Bye now, thanks.
Goodbye, Dr. Zulu.
Yeah, bye, Don, and bye, everyone.